Alright, so the LU factorization method is a method of solving a linear system of equation, right? We turn them into matrices of this form, right? And then we go through this process. We have this matrix here. We call this the A, this is the X, and then this is the B, right? And then for the A, we split it into the lower matrix, upper matrix, and then we go through this process, and then we end up getting our X, right? So generally the method is this way. You have the main matrix A, right? You find a way to get a lower matrix out of it, and then you do something to the lower, and then you get something we call the D, and then get to the U, right? Now we'll go through the process. We'll come back later, and then you see how what we've written here is related to the process, right? So this is what we'll do. We're going to go through it first. Okay. The method is pretty straightforward. Just have to follow the process. And then if you are doing something that you're doing in manual, even if when you understand it, even the manual method, if you want to create a computer system for it, it's much easier. So now we'll go into it. Okay. And because we are using a calculator, we're going to have one by to make our work easier. All right. So we've identified that this is our A, this is our X, and this is our B, right? So this is what we do. The first thing we do with this method is that, what do you say? The first step, as you see, now we are following the white arrow, right? So the first step is that we get the lower matrix, right? The lower matrix. So that's how we go about it. The lower triangle matrix from the E. Right? So to do that, we transform the A, right? So there's the A. So let's see. What we need to do now is to get the lower triangle, right, an upper triangle from this A, right? So let's get the upper first. Generally, by the method we use, we get the upper first, right? So we have this, right? So let's see. That's let's see, 3. Let's go straight for it. Let's go straight. So what happens here is that because we are trying to get the upper triangle, we use pivots, right? We are just doing elimination to get the upper triangle, and then the lower to get the upper triangle, then we get the lower triangle, right? So this is what we do. The pivot is now 3. The aim is to make sure that everything below this 3 here. Now we are starting with the first step, so let's take this one out. The purpose of the first iteration is to make sure that we turn everything below the pivot number 3 there to 0. And then what we are doing here, we just assume that the pivot is not 0, right? Or it will not be divided by 0. So that's what we do. To make everything easier, you formulate an equation that turns the one below this one to 0. So right. So when we start, we say this row 1, row 2, and then row 3. So if we want to find a new row where this 0.1 here turns to 0, we need a new equation, right? So we see something about row 2, right? And then you can use any equation, right? You can use an equation to just make sure that the 0.1 and 0.3 for the row 2 and row 3 respectively turn to zeros, right? But then there's I call it a smart way to do it. So this is how we go about it. When we are punching, basically because the row 1 is at the top, and then we are very familiar with XY, you can consider the row 1 values in terms of X and the row 2 values in terms of, now our aim is to we are concentrating on row 2 and the row 2 values to Y, right? So this is what we do. Basically, we just write row 1 here because that's the one at top. We consider that one to be sort of X, right? Let me do this way. And then we have a plus, and then row 2. Right. The only thing the only thing you must do next is to introduce something by the row 1, right? To make sure the computation is easy. So this is what we do. To make it very easy, the first thing to do is put a minus here, put it in bracket, right? And then you put a fraction here. The denominator of the fraction will be the number at the row 1, which is 3, the numerator will be the number on the root 2, right, which is 0.1, right? But when you point this, you see very clearly that the value at the root 2, right, then just the number below the 3 tends to 0. So let's see. That way your computation is much more easier, right? So we move on. We know that the root 1 is not changing, so we put that down, minus 0.1, and then we have minus 0.2, right? Because you are trying to transform this to an upper triangle, right? Okay. So an upper triangle of this sort. Just a reminder, we have this. Everything here is value, the rest are zeros, right? The rest are zeros. The rest are zeros. Okay, so now that's what we are doing. So we are going to the computation because we have the equation. Or should we write the second equation and go through it? Generally, it's safe to write the first, but leave the space. So let's see. This is what I'm going to do to make the work easier and safer. I write the equation for the first one, but I leave a space for the equation for the second, for the next row. That way, when I'm just done with this, I just go on and then complete the second one. So let's see. Okay, so I have this, right? So I write the 2 here. So now I'm working on the row 1. By just putting, I'm considering this to be x, and I'm considering the row 2 to be y, because x, y, the one at the top is x, row 1, the one at the bottom is the y, right? So it makes the work easier. So let's see. So what I'm pointing is minus, right, and the fraction, right? 0.1. What I have below is what? 3, and then a plus, right? The R1 is x, so let's see. Let's see. X, right, plus y, right, just y. Okay. So now I calculate when x is what? The x we said is the top one, that's 3. And the y is what? The one below, which is 0.1. And what does that give us? 0. So you see, we have the root 2 now. So here is 0. We do same when x is what? So now we are here. We are considering this 2, right? We do same when x is what? Minus 0.1. And y is 7, right? We get 7.003. Let's see if we can get a fraction for that. Okay, so that gives us 2, 1, 0, 1 onwards 300, right? We move to the next one. Okay, now what are we considering? Our x is what? Minus 0.2. And our y is what? Minus 0.3, right? And that gives us minus 22 on 75, right? Now we have row 2. Row 1 and row 2 already. We move on to row 3. It now is safe to write the equation, right? So new row 3, the bracket and the minus, right? The pivot is still there. So basically we are taking this one out. So let's see. This one here is out, right? So now we are considering just row 1 and row 3, right? So our aim is to find the elements of row 3, right? So this is what we do. The equation is now the minus, right? Then the fraction. We have row 1 here. Sorry, row 1 is the reference, right? And then row 3, right? The numerator is 3, the numerator is what? 0.3, right? So let's point that in. So we have a minus, we have a fraction, 0.3, and then we have 3, and then we have x, right? And then we have y. Now let's punch it. Our x is now what? We are on the third row. Our x is 3, our y is 0.3, right? That's 0. So meaning we are clear. Always the first one is to help you test, because the aim was to turn the one under the pivot to be 0, right? So the next one is what? Minus 0. Which is this right here, right? Minus 0.1, right? and the y is what, minus 0.2, right? And that gives us 19 minus, the negative is very important, minus 19 on 100, right? And then we have minus 0.2, and the y is what, 10, right? And that gives us 501 on 50. We are not done with the transformation. Our aim was to make sure that we get numbers just from here, right? And the rest here is 0. So we are just left with this one, right? So aim is to just transform. And when we are doing this, the next step that we are doing right now, the pivot is not the same as what we did initially, right? Pivot is something else, but we will look at it. Okay. So this time around, our pivot is what is this right here, right? So now let's see, just the same procedure. Our aim is to get a new row 3, right? So that's what we do. New row 3, the minus as usual comes, right? And we have something like the pivot here, and then the one you're trying to transform is the row 3, right? Row 3. Fraction sign, right? The one that are down, the denominator of this one here, what we put here, will be coming from the numerator, the upper one, because of how we've done the arrangement and everything. So that will be 2101, right? On 300, and the numerator will be minus 19 on 100, right? The negative can cancel out, so let's say this tends to about this cancel, it becomes positive, right? If you even want, you can leave them everything and punch everything, but it's just work. So let's see, that gives us a fraction at the top. That's 19 on 100, right? And then we have another fraction here, 2101 on 300, right? And this is x, right, plus y. So the first one is the one that helps us check that the equation that we are punching is what's the name? Is the right thing, right? So basically, first row remains the same, minus 0.1, minus 0.2, right? Row 2 remains the same, 0, 2, 1, 0, 1 on 300, and then we have minus 22 on 75. Is this so? Is this so? Let's see. Okay. Okay, so now let's test it. We have this, right? So when we try to calculate our x is what? Now we know that this one is out, right? So our pivot is this, and now we are doing this, guys. The ones that are zeros are fine. So our aim is now this ones, right? So let's see what we get. Okay. So our x is now that 2, 1, 2, 1, right? 0, 1 on 300, right? And then our y minus 19 on 100. And we are getting 0, meaning the equation is right. The equation that we generated to get the transformation is right. The next one, just punch on calc. We do minus 22 on 75. And then we have 501 1 on 50, right? And that gives us about 1912. You can use this mouse, and depending on the directions of the equation given, or just do 4 decimal places or something, right? So now we have this. Basically, we transform this to upper triangle, right? And this right here, let's see, this right here is an upper triangle, right? So the next thing now is to get a lower triangle. For the LU factorization has a unique way of doing this. So let's see. To get a lower triangle, this is how it's done. Okay. What happens is that we get a triangle, a lower triangle. So that means that here will be, we'll have something of this sort. Let's see. So meaning we'll have this here, right? To be values, the rest are 0. So here will be about 2 zeros, and here will be 1 0, right? And then the diagonals are 1 for the LU factorization. LU factorization, just for this one, right? So we get here to be 1, 1, 1, right? And what happens with the rest is we take the factors from the transformation that we did in the to get the upper triangle, right? So the first transformation that we did, so you see, this is R2, right? So that will be, let's see, this right here is R2, right? So that will be, we have only one R2 missing here, right? Oh, sorry. We have only one R2 missing here, so that will be here, right? And the next transformation that we did is just R3 here. So this is the first R3 we did, right? And this is the second R3. So that the factors that we use to transform will come here. So that's the process, right? So now we go on and get them. Because of how we did our computation straightforward, some of them might not be in simpler form. So then we use our calculator to help us. Okay, so let's see. So now the reason why we put the minus in the bracket was that we are not going to use the minus in finding the factor. So basically the factor here will be just 0.1 on 3, right? So let's see. 0.1, right, on 3. And that gives us 0.03, right? So what we put here is 0.03, right? So that's 0.1 on 3, right? The next one that we use, we go to the R3, right? And the factor that we use in that transformation, right? Let's leave it up. The factor that we used in that transformation is this one right here without the minus. So that's 0.3 on what? 3. And that gives us 0.1. Right, so the factor in this case is 0.3 on 3. And that gives us 0.1, right? So 0.1, which is the first transformation for the third row, right? Which is 0.1. The next one is this. We have all this here. In this case, don't omit the negatives, right? So punch everything in aside the negative in the bracket. So this is what we do. Fraction at the top, fraction at the down, right? So for the top one, we have a minus 19 on 100. The one below, we have 2, 1, right? 0, 1 on 300. And this is what it gives us, right? So about negative something. So let's see, minus 0.0. Let's do third decimal place. Let's do 4, 2, 7, 1. So that's it. We have our lower triangle as well. So the process was this. Let's go back. Okay. So we get from the A, we get our upper and lower triangles, triangular matrix, and then we find the with the L. We now have the L, right? We do something to the L to get a particular D something. So now let's do that. So what the next step is that with the L, now that we have our L, right? If you multiply the L by a particular matrix D, vector, right, which is D, we get the B that we have from the original problem, right? So the aim is to find the D, right? So now, right now, to make our work easier, I'm going to, but the D, if you do it this, it means that the D vector is going to be D1, D2, D3, right? But I'm going to assume that to make the work easier, that the D is equal to, let's say, about D, E, F, right, which is a vector, right? So now we go about it. So that will mean we have what we just found, which is 1, 0, 0, 0.03. We have 1. We have 0 here. We have 0.1. We have minus 0.0271. And we have 1 here, right? And then when we multiply by this D, which now we are seeing that D is D, E, F, but generally it should have been D1, D2, D3, right? It should be equal to our B, which is from the original thing that we have, right? where we said this B is this. So let's copy that and let's see how we go about it. Okay. That's the B. Now I'm putting here straightforward. Oh. Okay, so this is our B. And the next thing is just to do a forward elimination. So from this, we can deduce the equation that basically we know that this is what we can do. We can write out, this is D, E, F, right? D, E, F. So going through this, we have D plus F and saying 0, E plus 0, the 0, E, the 0 times F, giving us 7.85, right? This is what it's giving us. Meaning that we get our D to be equal to this 7.85, right? So now we get a concept. We can do the rest straightforward. What we have here is 0.03 D plus E, right? Because it's 0, we leave it out, right? And this is equal to the minus 19.3, right? And with this, we can find our E. So let's see. 0.03D, which we have already. And that's 7.85, right? Plus E, which we're trying to find, we make it X. Go to minus 19.3, right? Let's see. So our X is this. So let's see. Our X, which we are trying to find, which is the E here, is minus 19.5355. The next thing is to find our F, right? So with this, the last part, so we have a 0.1 D, right? Minus 0.0271 E, right? Plus F, and that gives us 71.4. Right. So the aim is to find what the F, which we don't know, and we have the values for E and D, right? So we go about it. 0.1, we know D, that's 7.85 minus 0.0271 E minus 19 minus, very important, minus 19.5355, right? That's E. And the X which you're trying to find, the F which you're trying to find, right? All this equal to 71.4, right? So it's 1.4. Okay. Okay. So I'm trying to find our F, right? So then our F is 70.040p. 856, right? So now we have our D. So the next step will be to that we multiply. So we've done two things with L. We found our L and U, right? And then we found the D. The next thing is to multiply the upper matrix by X and equate it to D and find the X now, right? So that's what we do. Basically, the next step is upper, right, times the X which you are trying to find. A minute. By the X that we are trying to find. And this gives us, this should be equal to the D which we just found, right? The D is just the DEF, right? So now let's do this. Where's our upper? triangular matrix. This is it. Okay, we are going to go through this straightforward and then find what we are looking for. Okay, so this is our upper triangle. Nice one. Okay. And now x, right? Which is what we are trying to find. Which is basically x1, x2, x3, right? But to make our work easier and clearer, we can just write this out and say let this x, right, equal to x, y, z vector, right? Here, instead of the x1, x2, x3, we just do x, y, and z. That way, you don't get any confusion, right? It's much more clear. So let's see. And it's equal to our DEF, right? A minute. Let's go to our DEF, right? Right? And we know the value for our D to be 7.85. Our E is minus 19. Minus 19, 53, 55. And our F is 70.0856. Right, so this is what we have. Now we do backward substitution, right? So we can see clearly that we have what's the name? 1, 9, 1, 2, 3 on 1, 9, 1, 0 z being equal to the 70.0856. So now we can find like z. Let's see. 1, 9, 1, 2, 3 all on 1, 9, 1, 0. The z is what we're trying to find, x, right? $70.0856. So let's see. That gives us a z of 7.0001 dp, right? Okay. Now I move on to the next one. XY. So we have here 2101 on 300 y minus 22 on 75 z, and that is equal to minus 19.5355. So this is what we're going to do. $300. We have our y, which we're trying to find. We have a minus 22 on 75. Z we have already, which is we are saying 7.0001. All this being equal to minutes. Okay. 2101 on 300 y, which we are trying to find, minus 22 on 75, right? Being equal to minus 19.53 5 5 right? So solving something wrong. Okay, the z, we have our z to be 7.001, right? Trying to find our y, right? We have z, we're trying to find y. So 2101 on 300 y, which is x, right? Minus 22 on 75. Our z, we have that to be 7.0001, right? All being equal to minus 19.5355, right? Now we have our y, which is minus 2.4963, 4 decimal places, right? The next thing is for us to find our x. So how do you go about that? Let's write the equation out. That's 3x. I need to find x, right? That's 3x minus 0.1y minus 0.2z, and that should be equal to 7.85. At times the z can get confusing, so for me, let's see, I'll make a capital. That way it's clearer for me. So I have 3x, trying to find that, minus 0.1 y. I have my y to be minus 2.4963, right? Then I have minus 0.2 z. I have the z to be 7.0001, all being equal to 7.85. So now we get our x. So let's see. So the x turns out to be 3.0001, 4 decimal places. These are the values that we have for the x, y, and z. So we said we made x to be equal to x, y, z. So this will be x1, y1 per the system, x2, x3, right? This can be confusing. That's why I did the x, y, z. Personally, this works for me. So this gives us x, this x1, so that's 3.001. Our y is minus 2.4963. And then our z, 7.0001, right? Yes. So this is what we have. So now we will go through the method and see why we summarize everything to how we wrote it up there. So let's see. So we'll go by it and see. So we said that the summary of the whole method is that we have the matrix, right? The matrix X, so the matrix A, right? We split it to an upper and lower matrices, and then the yellow sign is what's directing us. With the L, we find a vector that when we multiply by the L, we get the B, and then that that d that we found should be equal to, when we multiply the upper and the x, we get that d, right? So that gives us our x in the end. So generally, we summarize it to something of this way. So when you see this, you know what you're trying to do, right? So you have a, you turn it to upper and lower. With the lower, you just, after you found the lower, you multiply the lower by some form of d to give you a b, and with that d that you found, with this u here, you multiply the u by the x to give you the d. So that gives you the x that you are trying to find. So this is the summary of the method, and that's what we did. So we did all this transformation to get our u, and with the factors that we used to get the u, we transformed to get our l. With that same method, we just did with what we've had so far. With the l, we multiply by the d to get b. That helped us to find our d, which is def, we've written here. With that, then we moved on to multiply the upper triangle by the x to give us our d, and our aim was to find the x. So now we found the x vector, right, which we said we represent with x, y, z, but then it's originally x1, x2, x3, and this is what we have.